record this on camera. We have a bunch of AIs recording, and people are still straggling in. Okay, so we have three demos this morning to show progress. The first one, I kind of want to start from the ground up. So we'll begin with the Shard Composer demo. And just to set the stage, this is a tool for being able to quickly set up a shard um, and and then be able to over time monitor and maintain the shard. And then we'll jump to the other end of the spectrum and we'll show once you've got some shards running, then you want to be able to run some agentic flows over top of those shards and possibly other compute infrastructure. And once you have defined that, you'd like to be able to allow your community to interact with the agent you just defined. And so we'll demonstrate being able to install the agent you just defined as a user in a social network. In this case, a fork of Blue Sky called FireSky. And then we'll have some progress from the Roland team. They're stumbling towards greatness. We're going to see some bytecode being generated, hopefully, and some other things. So with that, I'd like to hand it over to Nash. Nash, are you ready?
Yep.
Awesome.
So let me just hang here. Is this legible to everybody?
Yeah.
Can
And
people read this terminal?
uh-huh.
Okay, cool. All right, good. So, um,
With a microscope.
is it too big? Is it too small?
It's
Hold on,
quite small. Yeah, if you could
tried to make it
maybe.
as big as I could. Let me start with just sort of restating the problem. As you can see, like the Firefly project has 56 different repositories. And knowing which ones to integrate and how exactly to get them integrated can be very difficult for developers. And then, getting it into production can be hard. Just the readmes for the Fire node itself are quite complicated. So what we wanted to do was to build a tool that made it possible to very, very easily, ultimately what we want is to just be able to run a single curl command, have a tool come down and be able to run shards, without having to go through a process of installing 40 different dependencies and that type of thing. So my terminal, and I'll show you guys how. Okay, so this is our systems integration project. This is what gets pulled down when you check out the tool. You can see that the way we've organized things is we've built a services definition file that integrates all the different components that we care about, like the node itself, the Rust client that we use to look at things, and then various different front end projects that all get built and integrated into this environment. The the tool provides a bunch of different commands to support launching. Right now, it launches everything in Docker. In January, what we'll do is we're going to swap out the Docker layer for OpenTofu, which will allow us to, launch containers and VMs in any provider that Terraform supports. So the first thing you do is you clone your project. That's already been done. It pulls down all the repos that you need. Then you run the build service command. This would take about 20 minutes to run if I let it go, but I'll just sort of start it and then fill it so you guys can get the flavor. It'll build all the services and all the Docker containers that are needed in one shot. And then once you've done that, you run, let's make sure we delete our data first. Okay, so then once you've done that, you run shard control up and it launches everything. And once that's happened, it takes a second. Once that's happened, then so now we have an environment that's got the nodes, it's got FireSky, it's got Postgres, Redis, the whole kit and caboodle already running, and it's got Grafana and Prometheus already running as well. So we'll just take a quick look at the validator logs. You can see that they're already processing Genesis. One of the things that we did as a part of this process is that we substantially improved the Asper Genesis protocol so that it only takes about a minute now. So this should actually finish doing Genesis almost immediately. And it's adding it to the DAG now. And oh, there goes Embers, putting its contracts in. Let's go over and we'll look at the fauna, see if everything came up clean. And this all just comes for free with shard control.
Uh, is it only for me, but I cannot see your screen, Ash?
Yeah,
I
I
have to
can't.
click share. Sorry. Is that better?
Yeah. Mhm.
Yeah, it's better.
Cool. So, and you can see the Grafana dashboard, the nodes, and you can see that they've gotten connected. Everybody's connected to 4 other peers. You can see various different metrics. And block validation rate is a 10-minute moving average. So it takes a little bit longer for this time series to come up than some of the other ones. But in a minute or so, you'll start to see block validation spike and the shard is running. So that's basically shard control. And then you can use that tool to bring shards up and down and to reconfigure them. And like I said, ultimately, we're going to support a variety of different cloud providers, anything Terraform supports for launching your shard. So we'll be able to provide you with the ability to generate OpenTofu configs or Terraform configs, and then control a shard using that as the underlying infrastructure as code layer. And that'll allow you to build shards in whatever topology you want, specify all the networking and that kind of thing, and then wire it all together very easily. And now you can see block validation has come up and we're now getting blocks validated on each validator. So that's the shard control tool.
Awesome. Thank you. That's
You're very-
short, sweet, to the point. Any questions about this? Awesome. Okay. Well, now we can move on to the integration of Embers with FireSky. Take it away,
Yeah.
Ihor.
Let's share my screen. Yeah. Can you see my screen?
Yes.
Yes.
Great. So this is basically agent teams UI that we showed like earlier in previous demo. So today we'll be showing how we can create an agent, publish it to FireSky. So basically create an account for him and start receiving requests from FireSky from normal users and replying on back to the social media basically. So let's start from creating agent. So we'll have it customized. Let's get some basic icon, agent name, maybe smart agent. Sorry. Agent. description.
It's so smart it
Um,
writes in Cyrillic.
what?
I said it's so smart it writes in Cyrillic.
Yeah. Let's say can do smart things, etc. Else these buttons we don't need for now. So in this UI, we can assemble our smart logic. So we'll do something like that. So we'll take user input, we will forward it to a text model. After that, we will generate image using text to image model, like so. Later, we will combine everything together, output from text model and the image. And later, we will send everything back to user. So like so. So we take going from input, the text model, text to image, combining everything, and will produce the result of it. Now we need to attach a deploy container to everything, and we can start deploying our agent to Shard.
So what you saw before, the shard control interacts with this, right? So the deployment container is something that you've set up through shard control. Does that make sense, guys?
Yes.
Cool.
So this is what kind of agents can one?
Well, the one he just described is one that glues together something that comes from the user and goes off to a text model, so like ChatGPT or any LLM. And then he just wired in a text to image, which would grab what's coming out of the LLM and turn that into an image, and then forward both the image and the text off to compression, and then make that available back to the user. So that's an
Right.
agent.
Exactly.
That's an agent made of agents. So it's agents all the way down.
Yeah.
And where do the agents live?
The agents can run anywhere. That's what the shard container, that's what
Right.
the deployment container is all about. You say where they're going to be run.
Yes, deployment.
The reason I ask is just if you have different types of agents
Mhm.
written in Meta, for, um, that would also work. It would be included
Yep.
in the.
That's right. And that's what the Metatron compiler is all about. So you can get lots of different agents all running on chain or on different shards, or you can even deploy them to other deployment situations, right? And we can call off chain.
Right. I'm just trying to understand how that fits into this kind of templated approach.
So again,
Input and output are very clear. So you just wrap an agent into.
you can have multiple ports. You don't even have to have a single input and output. Right? Because it's all underneath, it's all rolling. It's either rolling or rolling calling to something else. So a process has lots of different ports.
Okay.
They're not necessarily just input and output. For this flow, it's easier for people to conceive of that. But in realistic applications, you don't necessarily have simplistic input and output.
So how do you specify, where do you specify these ports?
When you saw the graphics, to tell you what, why don't we go through so you see
Sure.
the ports. The ports are just these the little bubbles. So you can have the bubbles. You can have, yeah, those little things there. You can have those anywhere. You can have lots of them. You can have only inputs. You can have only outputs. It's basically a port. When you connect two ports, that's the equivalent of connecting some channels, right? So
Right.
yeah. So
But I mean, specifically in which language? In Rolang? I'm not sure I understand.
so it's actually it's a bit more complicated. So like in terms of this graph, we compile the graph to a graph language, and then we compile the graph language to Rolang.
I can
Uh,
show Roland that we got from compiling it.
yeah,
It's
yeah. Let's go through the demo, and then some of these questions will be answered.
Okay.
okay. Yeah. Yeah. So this is the agent that we just created, the smart agent, and we have publish button here. This will let you to decide what kind of credentials you want, what PDS you want to use, and basically for creating both accounts. So let's do basic username like so. I will use PDS that I'm running locally, like this one. Some kind of mail, completely random, and password. So now we can just publish it.
Mhm.
Okay, it's done. So here I have a page with my account on the social network that we publishing our agent to. So if I look for a smart agent like this one, so we can see our agent has its own page. So we have smart agent test, the description, and the image icon that we used when we were creating agent. Let me check if I have okay, I have a wallet. And now when we create a post, I can say, like think, oops, sorry, this happens sometimes. Add the wallet. Now it should refresh. Yeah. We can ask any question. So let's describe the universe in 10 words. So we can probably sorry. And we can just post it. Was posted, and we can check logs that it's running. So maybe if I find the correct one, this one. Yeah, we see our agent was triggered. So describe universe in 10 words. This is a request we got from user. And we are generating image, we creating block. Okay, done, block is created. So when we go back to post, we should see, here it goes. So this is the answer from our agent, like I said 7 seconds ago. This is the result and the image that we generate.
Beautiful.
Okay.
Beautiful. Right. So if you look under the hood, we have a language for describing graphs. By the way, it handles both metagraphs and hypergraphs if folks are still interested in those sorts of things. But it has nice scaling properties. No worries, Marcin. Glad to have you back. So it has nice scaling properties. So as the complexity of the graph goes up, the lexical description of the graph stays nearly constant. And there are demonstrations of this if you're interested in graph theoretic applications of that graph description language. But anyway, once you have the graph description language, then it's easy to write a recursive compiler that compiles that to Rolang. You could, of course, target other things if you wanted to. You could go straight to meta or whatever, right? The point of having that abstraction is
Right.
that we have to go back and forth between the UI and the server with some kind of transport. And having a good scaling transport is important, right? Because those graphs could get really large, right? That was just a toy example, but if you're working on a really large multi-user project where these agents are very, very complex, then the description of that graph could be quite complex, and you want the description to be minimal in some sense. And so that's why that layer has been introduced. Right. So any other questions about what you've just seen or the architecture that underlies it?
I have a question regarding the connection between the graph itself and the underlying agent. Like what's the protocol that you then call the agent with? Is it gRPC? Is it something else?
Yeah, so between the front and the back end, they're using the ordinary deployment client. Ihor, you wrote the code, so correct me if I'm wrong, but they're using
Yeah.
the ordinary deployment client that every client of the blockchain or of Firefly uses, right? Which is gRPC based.
Yeah, so between browser, we have to use either basically gRPC on top of HTTP because, I mean, you only have this option for browsers. Yeah, but everything else is just, we have SDK, so everything is wrapped into nice TypeScript code with all the types, everything. And when it comes to, how to say it, and when it comes to Node, so Node has its own protocol on top of gRPC. So yeah, this is how it works.
Yep, exactly.
Okay.
So,
Thank you.
every application follows the same design pattern. So if you look at FireDrive, it's exactly the same design pattern, right? So the FireDrive is catching the file system events and turning those into gRPC calls against FireSky. So all of them follow the same pattern. So if you look under the hood, you'll see that all of these applications where we're demonstrating value are also templates for people to build applications against Firefly. Does that make sense?
Yeah, yeah.
So it
Cool.
all runs over your clone of Blue Sky, basically.
That's just the front end, right?
Front end.
Yeah,
Right.
yeah, front end.
Right. The back end is
I
Firefly.
didn't mean run over. I just meant through Blue Sky.
Right, right. Let's take a moment and imagine how this might come about, right? So someone who wants to deploy some agent-based fabric. So they pull up the shard control tool and they define a few shards where they're going to run various computations, right? And maybe they don't run all the computations in a single shard. They run them in multiple shards. Then they define some agentic flows, and the deployment containers for those agentic flows are the shards that were just defined, right? So you saw when he put the bounding box around that graph, right? He was saying all of these agents are going to either be run directly on nodes or they're going to be controlled by nodes in that particular shard.
Right.
Okay?
So Blue Sky, Fire Sky,
Yeah.
is providing the network.
Blue
Is
Sky is
that
not providing the network. That's what.
Blue
Yeah,
Sky,
so
Blue Sky is the interface for stitching all this together, right?
Yeah, that's
okay?
correct.
you can think about Fire Sky as the sum of Blue Sky and Fire Sky, so Firefly, sorry. So what you see the now on screen, you can basically attach this client to main Blue Sky network and have all the users, all the content, everything, and it will be running just seamlessly. You just need to use this front end, so we don't modify
Right.
anything in native Blue Sky protocol. We
Well,
just expand on it.
Is it fair
Well,
to
I
say
guess
that
it's
Metacycle provides the
Metacycle,
network?
yeah. Yes, that's right. Metacycle is right. So the shards are providing
Right.
the network
Okay.
communication flow, right? So think of Blue Sky as the front end, and then Blue Sky has its own protocol for stitching together certain kinds of information flows that have to do with the well, if you're I won't go into that. If you're familiar with the Blue Sky architecture, then you understand. Otherwise, ChatGPT or Google are your friends. Okay, and and then uh and then on the back end.
Right, right. So you are using the Blue Sky protocol. It's just talking between
Right.
the Fire network and then the Blue Sky interface.
That is correct. That's exactly right. Right.
But
That's
you can also have connections that get created on that front end between two different FireSky users
that is correct.
that then go back to each
That's right.
one's whatever's backing it, presumably a shard on each end, right?
That is correct. Exactly.
Is there a difference between what we call metacycle and fire network?
Yeah. So the simplest description is Firefly is just software, right? It's software that allows you to quickly build up shards and do all kinds of interesting applications on top of those shards. Metacycle adds to the tool suite basically the Metatron compiler. There are a few other bits, bobs and bits, but basically the main thing is the Metatron compiler. Once we have PETA integrated, then
Mhm.
it will also, the other tool that it brings to the table will be the PETA compiler. ChromaDB is much more infrastructure agnostic, right? It's not specific. So ChromaDB you can think of as more rightly living down in the Firefly region of the source code, right? But again, so Firefly and Metacycle, they're software, right? That's it. They're not services, right? Because when you say I've got a service, then you have committed to running machines for some period of time, right? Over the life cycle of the service, you've made a commitment about the uptime of those services. So, for example, ASI chain is making a commitment to its community. These servers are going to be up and running, at this level of functionality over this period of time, right? So software above that, services. That
But
makes
the
sense?
ASI chain also involves a bunch of smart contracts running on top of Metacycle and Firefly. So I mean there is software there running in the lower layers also.
Sure. Yeah. Yeah. The main point is that pretty much all the software that they've created, there's also an echo of that down in the Firefly. Like for example, the wallets, we've got wallets, or the monitoring, we've got monitoring. All of that, so they've Robin and his team replicated a bunch of stuff which they put off chain, that is an echo of the stuff that we have on chain. So, but yes, that you are correct. Um, okay, so unless there are any other questions, I'm anxious to see what the rolling team has done so far. Are you guys ready?
Yep, ready. Let me share my screen. One moment.
Okay.
In the meantime, you can just listen, Marcin, that the speech about what we are really doing. Marcin, are you here?
You are not audible, Martin.
Oh, it's like in the 19th century spiritistic seance. Marcin, are you with us?
We can feel your
Okay.
presence.
Crashed into
There we go.
Bluetooth.
Okay.
We can hear you now.
Let me make it right.
Nope, lost you.
Come and go. Nope.
Okay.
You want to try rejoining? All right, here's March and rejoining.
This is killing me, but
There you go.
Yes.
also I'm audible. Okay, I can't hear you now, but this time audible. All right, let's try it this way. Right, almost half a year ago, I'm setting up a stage here for what we're doing, what we have been doing for the past, well, this 6 months or so. So we set out to create a competing Golang implementation, but the one that's made right. to use a political expression, to make Roland great again. Why? Because we think that that Roland deserves a better implementation, the one that's high performant and bytecode based VM that's easy to transplant between various architectures we want to try it on. That's easy to extend, and well, has all the optimizations that the modern programming language needs to well, to create an ecosystem around it, basically, because it's a great language, but it needs to have kind of a reference implementation that's well that does the service to what Roland is. So that's our job, and it turned out to be devilishly hard, but still doable. So at this point, we want to well, show a bit of progress, because how do you present a programming language to the users? So we built some set of tools around it, namely the shell, or if you will, REPL, interpreter that you can interact with, and so on and so forth. We'll be adding various other tools to it so that it's easier for programmers and audience to interact around, to write around programs, and so on and so forth. These efforts are ongoing, well, and they will be for quite some time, if to be sincere here. But at the very least, we have some grounds for experimentation. That's what we want to show you. There will be two things that we will show: the bytecode generation in the shell and various goodies that we have in the shell, meaning in the terminal. And the experimental, let's say, if that's the right word in this case, a project that brings Roland to WASM, so which means basically you can work with it in your browser, but it shares the same implementation as it's not re-implemented for the browser. It shares the same implementation as the VM, the main VM. It's basically the same implementation, just recompiled. So that's also neat. I guess that's it, unless you have any further questions, of course. And if not, then I guess I'll give the floor to Adam.
Yeah. So let's show some examples then. As you see, I'm working just on some kind of the playground based on the WASM, our Roland just interpreter, but it's still under construction. So currently I just will show you exactly what we have just on the shell. So this is the shell. This is available when you just compile our branch. There is the create Roland shell, and this is just the binary by that in exactly that crate. So anybody can use it, and this is I think the place when we can show where we are. So we can make some mathematical just operation. So at least we have some kind of the calculator now after hard work, but it's working. For now, that our goal was to clip together to age of the process, the parser, then compiler, then bytecode generator, then virtual machine, and then presentation of some results. So all our hope is just for this moment we have exactly like that. When we just execute some code, we also can show just the bytecode. I already shared the special document with the composition of some examples and the bytecode. Not all examples make a sense, because it's still the problem with the limited just range of the language what we are already just supported. We're still working on the names, as Marcin says. We still working on the airspace implementation. For this moment, we have some kind of the fake airspace, to be honest. But we're working on that, and we're working on the representation processes in the airspace, because the process state must be just recorded in some kind in the aerospace. So that is the processes where we're working. But for this moment, we can execute some kind of Roland code. Let me just a moment. Like that. And more complicated, for example, let's do some list. And even more complicated, like manipulating with the channels. So for this moment, our iconic hello world. Oh, sorry, I have to reset just the buffer first. As you see, hello world working for now. And let's show the bytecode related with hello world. So we can do even more, even bigger, just examples. Reset. Like that. This is a lot of code. And the maximum complexity, what I just found for this moment, for our range, this is the last example from the file. And yeah, that is a lot of code. And of course, a lot of bytecode. So where we are, currently we can just execute some limited part of the Roland in our new interpreter. And now we very intensively just working and going to be able to split our code to the separated processes just represented directly in the airspace. And this is our goal. There we will have just working, completely working the Roland interpreter. So, and that's all from our side.
Thank you very much.
I want to add a little bit things about what Adam said about processes. We do not support truly parallelism for now, so it doesn't execute processes right. It's because it's very hard to find a solution that can work on that stage, because for true parallelism we need to connect R space, we need to connect names and support some additional instructions like spam async that handles the processes that affects current bytecode. So not all instructions look like they should.
Understood. No, yeah. I mean, effectively, what the compiler should be doing is creating lots of little strandlets where you have a bunch of arithmetic or built-in operations followed by an I/O, and the I/O event, whether it's a for or a send, more or less terminates that strand, right? And then all of those strands are running in parallel. That's the shape of what we expect to see out of the bytecode compiler. But we'll talk about that more in a different context. But yeah, I mean this is really good progress. It's good to see. Yeah. Thank you. And do you have a REPL just for the instructions? Like, could I just type in instructions and have those evaluated?
No.
Okay. All right. Well, I'm going to keep asking you for it.
Of course.
Right, because if we're going to have this intermediate representation, we need to be able to execute it right, because that will be an important part of debugging. Is
Yes, I'm going just to publish on even some server isn't a problem for me. That playground what I already showed.
Sure.
This is what I'm doing. When I will be finished, we will have just the playground, and you will check just directly from the web page how working just our current Roland interpreter.
Cool.
We almost have it, but we're not yet keen to show it, I guess, because it's in an early stage. So
Understood.
Understood. Yeah, we're keeping it to nature a bit, and then we'll show it pretty soon.
Understood. Thank you very much. So, no, it's good progress. It's really good to see things beginning to take shape. Any other questions from the SNet community or ASI community?
You mentioned execute instructions, Greg. What instructions are you talking about?
The ones on the screen, these are bytecode instructions.
Oh, okay.
All right. So the way the way underlying execution happens currently is you go straight from the abstract syntax tree to calls. It's an interpreter, right? So you run the AST either directly to primitive operations or to RSpace. So essentially, the AST is the instruction set. Here, what they've done is they've made an intermediate bytecode instruction set, because if you typically if you execute off bytecode, you'll find that many times faster. So that's they're working out the bytecode instruction set. We have a notion of what correctness is for the bytecode instruction set, which I've detailed in another document. And once this effort is a little more mature, we'll actually do a meta IL specification of the bytecode instruction set. So it will be very recursive.
Also, let me add that bytecode is easier to optimize.
Yeah.
So usually you'll get better execution, some better execution profile in terms of performance if you execute bytecode. That's what basically the JVM does, right? So it doesn't walk the language as it's represented after parsing stage, but it walks a intermediate representation, which we call bytecode. And these instructions you see are actually bytes that are, as in a processor, that are executed, but we just made a kind of a textual representation so that you can see something that's meaningful to human. But but these are like the instructions, and then the virtual machine, the implementation of Roland will no longer walk the AST over and over again, as was it was done like this in previous implementations, but it will execute only this instruction set. So think processor, which has a instruction set, which is like fixed in stone, and processor is made to execute it. That's basically what we are after.
Right. And this is exactly pushing, right? So the whole arc of the project, right? So there are many episodes and many seasons in this particular broadcast. But the whole arc of this many years of work is to drive closer and closer directly to the hardware. So we're aiming for an instruction set which we can then map onto RISC-V and other instruction sets. So I'd also like to give a go at mapping this instruction set once it's a little bit more mature against the Grok chip and a few others, right? So that's a part of our nefarious plans here to take over the world. Any other questions about this?
Well, so you brought MetaIL, so you want to model with MetaIL all these instruction sets, like including the ones which are very close to the hardware, and do some kind of verification at that level as well?
Absolutely. I mean, the whole point, like, if we can't do correct by construction, we should not be introducing any additional processing. So we have to have a theory of the instruction sets. That would be the meta IL specification of the instruction sets, and then a proof of by simulation, right? So if you were just to interpret the abstract syntax tree, programs that are bisimilar in that execution method would be bisimilar to ones that you've translated to bytecode, right? So if P is bisimilar to Q, then when I translate them to their bytecode representations, those executions are bisimilar to each other. Does that make sense?
Yeah, yeah, amazing.
Yeah, that's the whole point of the methodology. So, software doesn't pay for itself. You need payment instruments in order to have software be paid for. Now, Jeff, are you in a place where you can give us a demo of progress on the satchel?
Sorry, Greg, we need a little bit more time, maybe next week.
Okay.
We got the RGB transfers that we're working on, and we'll be able to show it off then.
Okay, no problem. Last 2 weeks ago, we showed sort of the initial designs, or sorry, maybe it was last week. I think it was last week. We showed the initial design for the satchel. Just to remind people, and you can look at those recordings. Some of those functions and features were mocked, right? And so they're moving towards making them actual implementations as opposed to just mocked. But the important point is that you can now define economic instruments which include, as a part of their computation, the agentic flows of the kind that we just described, right? So that's why FireSky has not only the flows but also wallets, right? So when you interact with an agent and are asking it to do stuff for you, it's going to um, it's going to say, hey, in order to run this, you got to pony up some tokens here, right? And the flip side is, of course, definers of agents that then share them with their community. They want to be paid out in terms of tokens or fiat currency, right? So we're introducing all of that infrastructure in a manner that is sufficiently general to do cross-chain value propositions, right? So you define compositions which have value in lots of contexts, and they execute cross-chain. So that's part of the functionality of the satchel that Jeff and Stephen have been working on. The other part is that it is backed by gold, right? So the Boring Financial Company is providing the infrastructure, the logistical infrastructure, the organizational infrastructure that connects the execution of these cross-chain financial instruments to gold backing. So that's another piece of the puzzle here. So any questions about that?
I have a question about the
Robert, you're
intermediate
very
mode.
weak.
Yeah, is it now better?
Much better, thank you.
Okay, so the bytecode, how high level is it? Is it high level or low level or mix of that?
Yeah, that's a really good question. What we found is that the row line concepts themselves, they cut across all the levels, right? So the extent to which the bytecode represents that kind of functionality, you can see it as cutting across the levels, right? And largely this has to do with the polymorphism of channels. So a channel can be a memory address, right? So that's very low level. But at the other end of the spectrum, a channel can be an SMTP mailbox. So it can also be a URL. So the notion of channels cuts across the grain of the sort of traditional levels in a deployment. Does that make sense, Robert?
Yes, thank you.
Sure. No worries. Um, right. So the piece that we haven't shown, but we did show it last time we spoke, is that it's all well and good to be able to rapidly define these flows and rapidly deploy them. But if you don't have any sense of the correctness of the flows, then you may, and especially if we're running it now in an architecture that scales, where with a handful of machines, say 100 machines, you can be running at twice Visa speeds. There's a problem in the sense that if your flows, if your agentic flows or your smart contracts are buggy, then you're just going to be running really buggy code at speed and scale, right? So the example I often give is the DAO bug, right? The reason Ethereum was able to survive that bug was because they were running at about 7 transactions per second at the time that the DAO bug hit. So now imagine that your agentic flow has a very serious flaw in terms of either leaking secrets or leaking financial, uh, um, assets. Then, if you're running at 100,000 transactions per second, that's a problem. Because that means in 1 second, you could completely drain a smart contract of all the assets that have been committed to it. So that's why all the Meta IL work and all the work that Christian is doing is so important because we want to be able to auto detect safety, liveness, and security errors. So you write down what you believe are the appropriate safety, liveness, and security specifications for your smart contracts, and we automatically check them. Now that's not going to catch every error. Not all specifications are immediately correct, right? So that's part of what makes development fun. But this is very, very different than the approach that we find with Copilot and the other AI approaches because they are proliferating very nasty bugs because they've been trained on code that has latent, very nasty bugs. So we're taking the other end of that telescope and saying, no, 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 you have to write down the properties that you want your code to preserve, and we will automatically check that your code has those properties. And
Well,
that gives
I mean, Greg, that should make it more appealing to use some of these LLM driven coding mechanisms, though, because then if your spec is human checked, then you can let the LLM spew out whatever code it wants, and if it checks according to the specification, then it's fine, right? I mean, it spares humans from having to read the LLM's code in many cases.
That's also correct. Additionally, you can play games like pitting different LLMs against each other in terms of both code and spec. But we believe that you need the specification part of this to go over the code with a fine-tooth comb. And then if you noticed from the demos that Christian was showing off, it's not just for checking properties of code. You can flip it round and turn it into a search mechanism, right? And so that's what we demonstrated last time with a graphical UI for searching against code. So the point here is that as you get more and more code being dumped into the Firefly shards, then you also have a search mechanism to go against that code, looking for code that has properties, safety, liveness, and other properties, which again makes it much, much easier to synthesize code. So specifically, you start with a spec, you go and check if you got any code that already does that. And if you don't have code that does that, you ask what gaps are there. So those are all questions that we can answer algorithmically. And then you can go and ask other shards, hey, do you have any code that fills the gaps? Right? And if at the end of that search you don't have anything that quite fills the gaps, then you can go to the LLMs and ask it to create code that fills the gaps. So the approach to the code synthesis is also completely different. And again, it's all embedded in a framework where those activities are recognized as economic activities that cost server time, and cost human time, and so must be paid for. So that's kind of the larger picture that we're talking about here. Is this making sense to folks?
Very much and very
Tons.
exciting.
Yep.
Yes.
There is.
Very cool. Very cool. Any other questions? We're coming up on the bottom of the hour. Any questions, comments, concerns, considerations?
How sure are you that Christian and everybody else that's working on this is, because it sounds like you need to be 100% perfect with your meta IL stuff.
I mean, I don't think you have to be perfect. The mitigating stuff here is there are two mitigating factors. One is the reason we've made meta IL so minimal is to have a surface area that we can check in finite time, right? Meta IL is not Perl with this gigantic surface area that nobody actually understands. And the other side of it is that we have all this category theory and concurrency theory and type theory that is guiding our every step.
Mhm.
So like nothing goes into production that doesn't pass muster both mathematically, theoretically, as well as, demonstrating that it scales. Right. So that's those are the bars that everything that goes into production has to pass in this correct by construction methodology. So are we going to make mistakes? Absolutely. Impossible to avoid them. Do we have a bunch of tools that are going to catch mistakes that are normally not caught in production? Absolutely.
Cool.
No, it's very impressive progress, Greg. I mean, I think a lot of things are coming together, which have been sort of growing for a considerable period of time. So it's a fun phase for sure.
Oh yeah, absolutely. Well, I just want to mention, right, like last year we were in Brazil and I suggested to you, hey, let's integrate social network. It's done, right? We just demonstrated the full cycle of integration. So you can not just run a social network on top of the shard, but you can define agents, multi-agent protocols graphically, and then turn them back into
Okay.
users in the social network. Right.
Wasn't that long ago that you and Adam cooked up Mork in Panama either. So Latin America has been very productive, right?
That's exactly right. More conferences in Latin America. That's right. Awesome.
Maybe it's time to change the setting. Europe.
Okay, there we go. Let's see if that works too. Yeah. Good. All right. Well, thanks everyone. Really
Thanks a lot.
appreciate all
Thank
your
you.
time, engagement. Yeah.
Thank you. Thank you.
Thank you.
Take care.
Ciao.